This video tutorial will provide an overview of the data management policies necessary for researchers who wish to receive National Institutes of Health federal research grants. This video will introduce the National Institutes of Health, the NIH, will provide a brief overview of federal open data initiatives, will provide an overview of the NIH data sharing policy, and will provide an overview of data management resources which will help researchers to meet NIH grant requirements. The National Institutes of Health is a branch of the Department of Health and Human Services. It is dedicated to providing resources for medical research in the United States. It is one of the largest funders of biomedical researchers in the world. The budget for the NIH is allocated by Congress. According to the NIH website, the NIH provides $32 billion annually to research. In the early 2000s, the NIH made a commitment to making research data and findings funded by the NIH grants available to the public. In 2003, the NIH issued a statement about sharing research data and the new expectations for grant applicants. In the statement, the NIH said, "NIH reaffirms its support for the concept of data sharing. We believe that data sharing is essential for expedited translation of research results into knowledge, products, and procedures to improve human health. The NIH endorses the sharing of final research data to serve these and other important scientific goals. The NIH expects and supports the timely release and sharing of final research data from NIH-supported studies for use by other researchers. Starting with the October 1, 2003 receipt date, investigators submitting an NIH application seeking $500,000 or more in direct costs in any single year are expected to include a plan for data sharing, or statewide data sharing is not possible." In 2009, the Congressional Appropriation Statement mandated that the NIH, in compliance with Public Law 111-8, all peer-reviewed manuscripts funded by the NIH must be deposited into the open access repository PubMed Central 12 months after the initial publication date. This public access policy adds an additional step to making research funded by U.S. tax dollars available to the public that paid for it. The Obama administration also made strides to increasing access to scientific research. In 2013, then-President Obama issued a memorandum entitled Open Science Executive Memorandum, which dictates that any federal agency with a budget over $100 million must make any data collected available to the public. An executive memorandum functions very similarly to an executive order. This means that the memorandum is not legally binding and can be more easily overturned. However, the open data initiatives by the Obama administration set the tone for open access measures within contemporary research. These open data policies by the federal government and by the NIH affect the application process in two ways. The applicant must prepare a plan which indicates the ways in which the data will be shared. The applicant must also be prepared to submit the final manuscript to an open access repository like PubMed Central and make the findings of the research accessible to the public. When preparing a data sharing plan, it is important for researchers to consider the data documentation necessary at each stage of the data lifecycle. A resource highlighted by the NIH is the Inter-University Consortium for Political and Social Research, or ICPSR. ICPSR has prepared a data preservation and archiving guide, which contains useful information that can be used when creating the data sharing plan required by the NIH. The data lifecycle consists of 6 phases. Each phase represents a stage which will involve data management. Phase 1 is proposal development and data management plans. This phase involves a lot of heavy lifting by researchers in order to create a plan for organizing, sharing, and preserving data in the long term. In this phase, it is important to understand the requirements of the granting agency, like the NIH, and to assign data management roles to the different research team members. Phase 2 in the data lifecycle is the project startup. In this phase, researchers should decide what form their data documentation will take. This decision will largely depend on the kind of data that is being collected and perhaps what software is being used. An important part of this phase is pre-testing, which will highlight any weaknesses in the data management plan and elements of data management within the research project that weren't initially considered. Phase 3 is data collection and file creation. In this phase, much of the data management plan will be implemented, including file naming, short-term data storage, and implementing a system of test subject privacy if applicable. The data management plan should address how internal data sharing necessary for Phase 3 can be streamlined and ensure consistency. Phase 4 of the data lifecycle is data analysis. Clear documentation of the methodology used in this phase is crucial to establishing the validity of the research and ensuring reproducibility. The data management plan should address how the documentation of the analysis will be conducted and stored. It will be very important to know the best practices in this phase and to adhere to disciplinary standards. Phase 5 is the preparation for data sharing. The data management plan should address which repository the data will be submitted to. Different repositories have different requirements. If, for example, the data will be deposited into PubMed Central, as is primarily the case for NIH-funded projects, researchers will have to know which supplemental materials and what file formats are required for submission. Phase 6, the final phase in the data lifecycle, is depositing the data. As with Phase 5, understanding the rules and standards of submission should be understood and addressed in the data management plan. It is also crucial to understand that this is not the end of the data management lifecycle. Long-term preservation, rules for sharing the data, and clear ownership of the data all occur before and after submission. Making sure that these issues are addressed and that funds are allocated for preservation are important to include in the data management plan. Apart from the data lifecycle, ICPSR also breaks down the different steps that should be included when making the data management plan. These steps correspond with the different phases within the data lifecycle. The steps are data description, review of existing datasets, format, metadata, storage and backup, security, responsibility, intellectual property rights and data ownership, access and sharing. As was previously mentioned, creating a data sharing plan is only the first part of the NIH Public Access Policy. The second part is the submission of the final manuscript into an open access repository. Commonly, this repository is PubMed Central, which will make the manuscripts publicly available 12 months after the manuscript's initial publication. The importance of protecting test subject privacy is underscored many times in the NIH application process. It is important to make sure that your data sharing plan addresses these privacy concerns and outlines clearly the steps that will be taken to ensure privacy. These steps can include double-blind data collection, data naming and labeling structures in which the identifying information, such as names or birth dates, are not used, and the incorporation of pre-testing, which proves that the measures that will be taken do adequately protect test subject privacy. The NIH provides guides and resources to help researchers develop their data sharing plan. An overview of the NIH Public Access Policy is a good place to start. The FAQ page answers frequently asked questions about the NIH's data sharing policy and acts as an index to help researchers find helpful web pages on the NIH website. Submission guidelines for preparing to submit to PubMed Central can be found both on the NIH website and in PubMed Central. These are the resources that were used in this tutorial. Thank you.